Hello everyone, welcome back. The third type of oblique triangle that can be solved using the law of sines are those triangles under SSA situations. Please be reminded of that the first two types of oblique triangles that can be solved under the law of sines are those triangles under AAS and ASA situations. This is a unique situation here because for SSA situations, there are some concerns that may not be true or there might be more than one triangle that can be formed. That is why I separated this so that I could also discuss this to you and make you understand that there are plenty of situations or plenty of situations that will happen under SSA conditions. Notice that we only have one given angle here. So if we have to draw, say for example, any triangle, okay, here, and we have here the angle, okay, given that if this is an angle, the the other sides are not necessarily these two sides here because the angle is not an included angle. So hence, say for example, this is the first side and the third could be probably here. Okay? So again, this is an example of an SSA situation where an angle is not included. Now, why is it that there are some concerns as to this situation, and why is it that some of the references will call SSA situation as an ambiguous case? Because I have mentioned earlier, there are some instances where there can be no triangle formed. There could be only one triangle that can be formed, and there is also an instance where our given might represent two different triangles. I'm talking about this concern. Take note that one triangle that can be formed here might be this one. Okay? This is a given possible triangle if this is an angle here. However, what if it will also look like this? Meaning that this side here is not this long, meaning this is even shorter than the first side. So we could also have this given triangle here. Hence, for this situation, this could be the given triangle or the other way around. This is a possible situation where for a specific given, there could be two possible triangles that can be formed. So before we could solve items 1, 2, 3, and 4 in determining the unknown measurements or the remaining measurements of the oblique triangle, let us first determine the number of oblique triangles that can be formed in these given situations. We do have differences and criteria in determining how many triangles that can be formed here. First and foremost, if our given angle is a is an acute angle, just like this. For number one, the given angle is an acute angle here. In number two, it is an obtuse. Number three is a right. And number four is actually considered to be another acute angle. And of course, do not forget that the notations used here, when we use lowercase letters, those are actually the side directly opposite the given angle here. The remaining would be the side that is either on the left or the side of the angle. If I'm going to minimize this, I have here a list of conditions. Okay, so I'm just going to give this to you directly. If ever our acute angle is less than 90, or it is an acute angle, we have four possible situations. If our given angle is obtuse or right, there can only be two possible situations here. So I might explain this to you in this form. I'm also going to share another digital tool that can help you understand this better. So let's start with item number one. I'm going to talk about this better in our using a digital tool, which is actually a Geogebra. But for this case, let's just continue with our process here. So for number one, it is an acute angle 47 degrees. So it falls on this category. Now, for an acute angle, there could be four possible situations. But first, we need to understand how will it work. Notice here that we might have a difference as to what angle is being emphasized here. In our given is C. In the general situation is A. So definitely A here and the A meaning here is the side directly opposite the angle. So in this case, this situation's here. So the first thing we need to understand after we have known that this is an acute angle is to determine what is the relationship between its opposite side, which is C, and the other side, which is A. This is its opposite side. This is its other side. Okay? Now, looking at the value, we know that the opposite side C is actually bigger than A. So we have this situation here. Now, looking at our SSA possibilities, we only have one situation that tells us whether A is greater than or equal to B. In this situation, we could only say that there is only one triangle that can be formed with these situations. Again, do not be confused. We are not yet solving. We are just determining the number of oblique triangles that can be formed in this given situation. Again, what happened in number one is we classified what angle is it. And since it's an acute, so it falls in this category. So between or among these four, which should be followed, we look into closer into the relationship between the opposite side and the other side. Don't be confused again with the notations used here, because in our summary here, as a summary, this is with regards to an angle A. That's why the opposite side is A and the other side is B. And here, since the angle is C, so its opposite side is small letter c, and the other is also A. So we only have one triangle here. And that triangle will be used or will be solved later on our next practice exercise. Let's go to number two. Our angle here is an obtuse angle. So it falls in this category. This is an obtuse angle. So it's an obtuse angle. And for an obtuse angle, we only have two different situations. It's either there's only one triangle or there can be none. So let's look at the relationship. Since the angle here is B, so the opposite side here is side small letter b, and the other side is side A. Looking at the value, B is greater than A here. So looking at the situation for an obtuse and the opposite side is greater than the other side, there's only one solution. In short, we only have one triangle here. And we are going to solve the same triangle later. Let's proceed to number three. Number three is where an angle is right, so it falls in this category here. This is a right angle. The opposite side here is side A, and the other side is side C. Now look into the value of the given. We have here C and we have here A, which is very obvious that A is less than C. In this situation, it falls in this category. Therefore, there can be none. There is no triangle that can be formed here. Again, I'm going to show you the possible situation in the Geogebra later. And for the last item, by the way, in number three, there is no triangle. Therefore, if this will appear in our next practice exercise, then we cannot solve the rest of the measurements. And finally, in number four here, we have an angle which measures 12 degrees. In short, this is also an acute angle. So this condition, or this situation rather, still falls on this category here. Now we need to identify which is which. So the opposite side of angle B is side B. This is the opposite side. And the other side is side C. However, as we know with the given, B is less than C. Again, don't be confused as to why these situations use A and B, because in this situation, the angle being given is angle A. So in this case, this first situation is no longer possible, and hence we need to trim down the possibilities into any of these three. So the three situations is where first there can be two solutions or two triangles, and then there's only one or there is none. In order for us to do that, we need to understand that we should not end in this, because the three situations share the same concern that the side opposite the given angle is shorter than the other side. Hence, we need to identify the relationship between the opposite side, and the other side multiplied to sine of the given angle B. Again, here you might see A is greater than B sine A, or equal to B sine A, or less than, because B and A here are what was given. Since we are given with these sides and this angle, we need to use our analysis in implementing this one. Then which is which between the two expressions here, we will know how many triangles will be formed later. So B is equal to 8 and C is 12, and then sine the angle B, which is 12 degrees. So let us take this whole expression and get the value so that we would know what is their relationship. To do this, let's use the same calculator I shared before, this one, and let's take the value of this. This is 12 times sine of 12 degrees equals, which is 2.49 rounded off into two decimal places. Hence, this is again approximately 2.49, and B is equal to 8. And obviously 8 is greater than that. So looking at our situations earlier for SSA possibilities, where the opposite side is less than, or the measurement of the opposite side is less than the measurement of the other side given, we have here this situation for this triangle. And hence, we would expect two triangles for this expression. And for these two triangles under this situation, if we are going to use later on the law of sines, we need to solve both of them. Now, I mentioned earlier that I also have something to show you that could be further proof for these situations here. I am talking about the Geogebra digital tool in mathematics, which is actually a compilation of activities and materials prepared by different authors, which you could use the concept of geometry and algebra at the same time to understand one another. So let's use this one here. So I'm going to extend this here so that I could see, or we could see, the bigger picture. And let's use this area here. Okay. So in our analysis earlier, number one, with this given, could only satisfy one type of triangle, or one oblique triangle. Let's try to use this GeoGebra prepared by Patrick Kennedy to see if there is only one possible. Okay, so you have the angle C, which is opposite angle A. So angle A here would be angle C. Please be guided with the given. So this should be 47. Okay, you will see a figure here later on as we input all of this. So we have here angle A. This A here is the opposite side. In this case, it should be C. So this is 20. All right, 20. So you could already see a figure like this. We have the value of the other side, which is 13. That corresponds to letter B here. So 13, 13 something. Sorry, 13 here. As you can see, given the figure, right? And there's only one triangle that can be formed using this given. And our analysis earlier is correct. Please do not be confused with this height here and you would say there are two triangles. This is just a height of this given triangle. And it doesn't represent two triangles here because this is angle 47. This is side 13 and side 20 for A, this one here. Okay, it shows this area here for just one triangle. So this is another proof for number one for our answer. So we are going to solve this triangle on our next practice exercise. Let's proceed to the number two. But the value is too large because of the maximum value for the side here, if I'm correct, is 50. For the non-opposite, or the adjacent, or the other side, the opposite only has 20. So if I may, please I beg your pardon, let's just use 4.5 and 3.9 just to um, illustrate the given. So it's still 97. I don't know if we could reach 97. Yes, 97. Okay, so we are going to use here 4.5 for the opposite. And take note, this is the opposite side here, not this one. Don't be confused with B and A here again because the angle given here is B, so its opposite side is small letter B. Here, it's A and A. So let's have it 4.5 in this area here. 4.5. And then this would be 3.9. Just to emphasize lang. 3.9. As you can see, it is an obtuse triangle, oblique triangle, that is only one triangle. So it satisfies the situation here. Only one triangle is formed by the given. Number three is where we have here the situation, 90-degree angle. So let's increase, let's have it 90, 90. And then the opposite side, A is 21. So here is 20. Oh, it will not reach 21. So let's just again use, okay, 2.1 just for illustration. 2.1. And the 3.2 for the other side. 3.2 for a little bit, for a while. 3.2. As you can see, even if I'm going to just, what do you call this one? Zoom in or zoom out, there can be no triangle. Notice that the angle is 90, hence it should be a right triangle. And the opposite side should be longer than any other side because the opposite side of any right triangle is the hypotenuse. And the hypotenuse is always the longest in any right triangle. Just for looking at the situation, there can be no triangle and our answer is correct. Now here comes the tricky part for number 4 because this is earlier we solved it to have two triangles. Let us see if there are really two triangles formed here. So our angle is 12 degrees. 12. That's it. The opposite side is 8. And the non-opposite or the other side is 12. 12. Let us see. Okay. So here you would see two triangles, again with the exemption of the height. The first triangle is where the angle is 12 degrees. The opposite side is somewhere here. I'm talking about the biggest, okay, the biggest triangle formed. Angle is 12 degrees, and this is the opposite side. This one here. Let me pause it in this manner. Pause. Okay, somewhere there. Not this one, but this side here, using the B2 as its another vertex. So, yeah. So this is 8. So 12, its opposite side is here. And 12 is somewhere here. This triangle is where the angle included between the given sides, B and C, is an obtuse. That's one possible situation. The other triangle that can be formed is the smaller one here, where the angle formed between the two sides, for a while, let me, yep, I cannot time it properly, but the angle between the opposite side 12 and 8 is this acute. So we could have this triangle and we have also this triangle here possibility. This is the reason why there are two triangles for situation where the value of the opposite side is actually shorter than the other side. Again, don't be confused with B is 12 and B is 8 here because B in this figure is the opposite side, but here B is, by the way, because B in this given figure is the other side and here it's the opposite side. So this is actually a mathematical digital tool you could use also to check how many cases you will have for a given situation. So let me take it down. So these are the answers for this practice exercise because our task is only on determining how many oblique triangles can be formed. In the next practice exercise, we are going to solve the angles, or rather, the triangles formed in number 1, 2, and in number 4, both the triangles in number 4. Of course, number 3 has no other triangle, There can be no triangle for this situation, so we're going to skip it if this will be present in our next practice exercise. So use this as part of your preparation because the SSA possibility or situations is actually the third type of situation where you can use law of signs, but this is where the situations are too ambiguous and hence it is oftentimes called ambiguous case. So aside from AAS, ASA, the third for law of signs is SSA, and we are going to show it for the next practice exercise. Thank you very much. Goodbye.